Good morning to everyone. Am I audible?
Yes, sir. Good morning, sir.
Clear and loud, right?
Yes, sir.
Okay. For 5 minutes, we'll discuss, or you should tell me what you learned in the previous lecture. So, roll number 9. Please respond. Roll number 9. So, roll number 9. Are you getting my voice? Roll number 10.
Yes, sir.
So, what is this Diffie-Hellman algorithm?
Sir.
What is the Diffie-Hellman algorithm? Yesterday we discussed.
It's sharing sir, between sender and receiver.
Okay.
Secretly.
How?
Like.
So only key sharing. Is there any encryption process?
No, sir. On this secret key will be further more to encryption, sir. There is no encryption in this.
There you go. Okay, right. Okay. Okay. Number 20.
Yes, sir.
What is the concept behind this key exchange algorithm?
I don't know, sir. Last class I wasn't there, so I don't know anything about last class, sir.
Upload a video in our channel, YouTube channel. Please, okay, just watch.
Okay, sir. I will, sir.
Yeah. Talk about roll number 11. Roll number 11.
Yes, sir.
Yeah. So
Sir, yesterday I'm absent, sir.
Okay. Roll number 27. Are you there? Roll number 30. Roll number 30. Roll number 30 absent. Okay. Roll number 30 absent. Roll number 39. Roll number 39. Okay. Camera रहेगा बहुत. Roll number 45.
Sir?
Yeah. So, were you there yesterday?
Yes, sir.
So, what is the concept behind this key exchange algorithm?
Sir, A and B to if one is sender and one is receiver, sir.
Okay.
both don't know each other's keys, but
Okay.
finally they will get the same key, sir.
Yeah, that's right. I mean, what is the first step in the key exchange process?
Uh, uh, I don't know exactly, sir, but
Revise, the 5 minutes, you should revise for 5 minutes at least. It's a simple process. Please try to revise in the next lecture, okay?
there'll be KA and KB.
That's okay. That is the final version. Actually, what is the starting, process? That is what I'm asking.
1 second, sir.
You have. Roll number 49. Roll number 49.
Yes, sir.
Yeah. So do you know the procedure or process?
Yes, sir.
Yeah. So what is the first step in the key exchange process?
Finding the alpha value, sir.
Okay. Before that, we should select something, no? What is that?
Prime number.
Yeah. First step is we should select a prime number.
Prime number.
Then
And
we
next,
have, you should compute alpha. But what is the alpha is called?
primitive root of
What you choose in the
prime
prime.
number.
Very good. Okay. How can we choose this primitive root? Do you know the procedure?
Yes, sir.
Can you tell?
For the prime number, we have different numbers. I do.
No.
One.
Okay, I have written as a row wise 1 to q minus
Yes,
1,
sir.
column 1 to q minus 1, then powers like that, no?
Yes, sir. And after that, alpha square into q and so
Yeah,
on.
alpha square mod q, alpha
Mod
cube
q.
mod q, alpha mod q should generate or should have the numbers, distinct numbers 1 to q minus 1.
Yes, sir.
Okay, 63. Row number 63. Is my screen is visible?
Yes, sir.
Row number 63. 64. 64. 65. 66. 61. 58. 58, 61, 62, 63, 64, 65, 66. Not responding.
Sir, 58.
Yeah. Okay. Yesterday you were there.
No, sir, I had supply.
Okay. So videos are there.
Yeah, I will watch, sir.
Watch it. Just you can easily answer the
Yes, sir.
in good exams. Okay.
Yes, sir.
Okay. So today we will see some example problems from this Diffie-Hellman key exchange. But before that, I will revise what is the process. This see, then we will do 1 or 2 problems based on the complexity. Okay, all of you getting my voice clearly?
Yes, sir.
Okay.
Yes, sir.
So the Diffie-Hellman key exchange algorithm starts with a prime number. So we can assume P, Q, etc. So if I'm assuming
Sir, your
Q,
voice is very low.
oh, okay, I will increase it. So first we should choose a prime number Q. Now is it okay?
Yes, sir.
Yes, sir. Now it's okay.
Okay. So what is the second step? We have to compute alpha, which is a primitive root, of Q. So how to find? And the alpha must be less than Q. Yes or no? This is the condition, right? Yes, please confirm.
Yes, sir.
Yes, sir.
So, how to find the primitive root? So, if alpha mod q, comma alpha square mod q, alpha q mod q, and so on, alpha power q minus 1 mod q should have the numbers, distinct numbers that is 1 to q minus 1. Then we can say alpha is a primitive root of q. So that procedure I have discussed. So we should write 1, 2, 3 up to q minus 1, 1, 2 up to q minus 1. This will be the number we should consider at a time, and this will be the power. Then we can perform the mod q. Yes or no? Yes, is this clear?
Yes, sir.
1 power 1 mod q, 1 square mod q, or 2 power 1 mod q, 2 square mod q, and so on. This is the procedure to find the what is called primitive root of q. Then what is the process, actual process? Yes, anyone? Once we know q and alpha, what is the next procedure? Yes.
Choosing XA and XB.
So we have to, randomly sender and the receiver will choose XA and XB, which are what are those called? XA and XB. So
Private.
private keys for user A and user B. Yes or no?
Yes, sir.
Suppose user A, user B are there. So first he will select randomly XA. Again, it must be less than Q. He also select XB, which must be less than Q. So there is no what you call dependency on these two numbers. So he will choose randomly. He will choose randomly. Then he will compute what you call. This is YA is called what?
Public key.
Yeah. So this will be called private keys, and this will be called as a public key. So this can be found by alpha power XA mod q, correct? Yes or no? Similarly, YB is
Yes.
equal to alpha power XB mod q. So these are the two public keys that will be shared to, so this A will be shared to the B and the B will share to the A. Now using this private and public key, this side he will generate a key, which is, what is this? This fellow will use this public key, that is YB power and private key XA mod Q, and this side KB equal to, he will use public key of user A, YA power XB mod Q. Is it correct? Yes.
Yes, sir.
And these two will be identical to each other, which is the actual key which will be used for the encryption process. So once the key is shared, then only the actual encryption process will start. Okay? Will be used. Okay? Is it clear to all of you?
Yes, sir.
Right. So now we'll see what are the difficulties we will face when we are taking the alpha value or a q value from what larger value. How to perform the generating the. So these procedures are called generally discrete algorithm. So it's very difficult to, or we can say impractical to determine the keys. If I know what do you call public key, generating XA is somewhat difficult, very very difficult, because this is a discrete algorithm. So that we will see anyway in the next lecture. What are the difficulties? Now we'll see this problem. Everyone, please note it down. This So Diffie-Hellman scheme with a common prime number q is equal to 11, alpha is equal to 2. But user has a private key, he is choosing xa is equal to 10, and we have to generate his public key. Similarly, user B has a private key as a ya is equal to 10. Okay, don't take it as a 10, take it as a 8. What is the secret key shared with A? So all of you got the question? Ya take it as a 8. Maybe I'll take them down. Yeah. So xa is 10, ya is 8. So what is the secret key k shared with A? So please take this and tell me what is ya. All of you should put it in the chat box your answers. I'm giving 3 minutes time to you. If anyone did not understand, you can ask, or you can so what is your doubt, you can ask. Meanwhile, I will discuss with you. Anyone having any question, you did not understand, etc. Oh, one. All of you are doing, please confirm.
Yes, sir.
Roll number 34. Manually you performed, or did you use any program?
Sir, I used calculator.
Oh, I mean, just I mean the formula and calculator. That's it.
Yeah, that's it.
Okay, fine. So similarly, go for YB and finally find the K also.
Sir,
Yeah.
in the first problem we don't have xb, no sir. So how to find yb in first problem, sir?
Yeah. So maybe so YA in the sense it is a what is called? Oh, it is not YA.
YP, I think so.
Yeah, it is XB, not the YB. I'm changing this. It is XB, okay?
Okay, sir.
Yeah. So actually, it was something like this. They have given public key and we should generate a private key, but that will be very, very difficult. So that's why I changed, but I forgot to change the letters. So XA and XB, okay? So here 34 said it is 1. Yes or no? So what about here? YB and KA, K. Yes? Anyone? Answer? YB is 3. Okay. Is this correct? And similarly, find KA and K. YB2 K is equal to so number 10. Okay. So that means KA is equal to 1, KB is also 1. Okay. All of you got these results? Then this will become very easy to detect the encryption key. Is that not? A secret key. So brute force attack, they can easily identify the secret key. So that's why we will try to take prime number large value. That I will show you in the next problem. So do you need some more time, or shall I discuss this one? Please confirm. Okay, roll number 41. How many students? Please confirm. All of you got the same answer or not? At least. Number 9.
Doing, sir.
Number 1.
Finish, sir. I got the same answer.
Number 2.
Yes, sir, got it.
Number 60. Number 60. 63.
Doing, sir.
Okay. You know the concept question. Okay, no? Concept is understood. 66. Number 66.
Yes,
65.
sir.
Yeah. Are you doing 66?
Yes, sir. Doing, sir. 66.
65.
Sir.
64.
Yes, sir, I'm doing it, sir.
63. 62. 57. 58.
Sir, got it.
51. 51. 52.
Doing, sir.
52. 52. See, you have to practice. In the exam, they will give very large number. It may take 5 to 10 minutes for only one question. If you don't practice now, it may take half an hour also for one question. We may not do 2, 3, 5, 10. I may do large numbers. If you practice, you can get it. So don't think that you will get the answer from other person. So we'll try to view different questions. If you don't know, yes, please ask. I will do multiple problems. Yes, all of you, please confirm. Whoever is not done, please see here. So Q is equal, I'm doing C, all of you, I mean whoever is not doing, Q is equal to 11, alpha is equal to 2. In the previous lecture, we have seen that for 11, 2 is a primitive loop. Yes or no? Please confirm.
Yes, sir.
Xa is given as 10, xb is the 8. Then what is ya? Just now we have seen alpha power xa 2 power 10 mod 11. Similarly, yb is 2 power 8 mod 11. Yesterday, okay, 2 power 10 means 1024 mod 11. This is 256 mod 11. So when you divide 1024 by 11, so you will get a remainder as 1. Yes or no? Because 1024 divided by 11. That means 93 times when you perform 93 into 11. 93 into 11 will give 1023. So 11 into 93 will give 1023. So the remainder will be 1. Similarly, this fellow also is giving us 1 on 256 divided by 11. So 23 times. 23 into 11 will give 253. No, this is a 3. Yes? Yes or no? 11 into 23 is giving us 253. Please confirm. YB is 3. Am I correct?
Yes, sir.
Yeah, YB is 3. Okay. Then what is the KA? KA is YB power XA mod Q. That means 3 power 10 mod 11. Here KB is 1 power 8 mod 11. Anyway, this is 1 only. So when you take 3 4 10 mod 11, it should also give 1. Yes, 3 over 10 is 59,049 divided by 11. 5368. 59048. So 1153 5368. It is giving 59048. So remember will be 1. So the shared key is 1. All of you got it?
Yes, sir.
Now, yes, everyone should see carefully this one. Alice and Bob use the Diffie-Hellman key exchange technique with a common prime Q, which is 353, and a primitive root alpha is 3. Now, if it is a offline exam, we may provide some Q is equal to 43 and find alpha value. It is somewhat difficult. 23, find alpha value. 15, find alpha value. Okay. So as we start, I mean, if you know any language program, you can easily find out what is the primitive root for 353. But alpha is given as 3. That means it may be primitive root for this one. Now see carefully. XA is given as 97. That means XA is what? Private key. So find her public key. So we have to find YA. Choose XB as a 10. So find his public key. Bob has a private key. Is this? Find his public key, which is YB. And finally, what is the secret key shared between these two fellows? Now here it may take some time. So any suggestions from your side? All of you have taken this problem, please. Q is equal to 353, alpha is 3, XA is 97, find YA, XB is 10, find YB, and also we have to find the secret key which is shared between Alice and Bob. So please confirm. Have you taken this? Shall I proceed? I will do this so that you will get some what is called idea when we give something like this very large numbers, how to proceed.
Sir, can you also show how to find alpha also?
For this one,
For anything, sir.
okay. I mean, yeah, I will show it. But for this one, it's we cannot find because pages will not say we should write 1, 2, 3, 52, something like that. I will
Yes,
show
sir.
for the small number. All of you see carefully who don't know how to suppose q is equal to I will take 15. Okay, na? Now 15 is a prime number.
No, sir.
No, right? So I should not take. 13 I will take. Okay. 13 is okay, right? Prime number.
Okay, sir. Okay, sir.
Now see how to write. So write down 1, 2, q minus 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. This side also write 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. Actually, we may get 2, we may get 3, we may get 4, we may get 5, or something like that. No need to go for 12 also sometimes. Roll number 39. Roll number 39. Okay. Roll number 39.
Sir.
Wow, why are you late, ma'am?
No, sir. I joined at the starting only, but due to network issues, I rejoined again.
Okay. I was thinking that you are joining now, so I didn't allow. Okay, no problem.
Okay.
If someone is, say, all of you listen, if someone has another problem, he joined but disconnected, make a message. Okay, no? Put it in the chat box by, I mean, you can call to your friend and message me. I will allow. So this will give the power on the mod q. Mod q means mod 30. So all of you, is it clear how to write this? So this is the powers. This is the numbers we are choosing. Example. Sorry, not example. We are going for the trial and error method. I can choose any number from this. Okay. Clear?
Yes, sir.
Right. So anyway, 1 power 1, 1 square, 1 cube, 1 power 4, whatever we do, I will get only 1. So anyway, we can eliminate always 1. Clear?
Yes, sir.
Now 2 power 1 mod 13. How much value? It's a 2 only, correct? 2
Yes.
power 1 mod 13 will give 2 only. Next 2
Yes,
square,
sir.
4 mod
4.
13, 4.
4.
2 cube, 8. 8 mod 13, 8.
8.
2 power 4. So 2 power 4
3.
mod
3,
3
sir.
means, so
3, sir.
16 mod 13, so remainder will be 3. So 3. 2 power 5,
19, sir.
32 mod 13 will give 19, huh?
Yes, sir.
No, sir. No, sir. No.
No, no, no.
2, 6, sir.
Oh, sorry, sir.
13 twos, no, 26.
Yeah, yeah.
Next, 2 power 6, 64 mod 13. How much? 13 threes, 13 fours, 52.
8, sir.
So 8, huh?
Sorry, sir. 12, 12. 12.
Yeah.
12, sir.
First. Next, 64 తర్వాత 128 mod 13. How much? 13 tens, 130. No, 39 set mark.
11, sir. 11.
Answer is 11. Huh?
11, sir.
Okay, ma'am. 256 mod 13. Just use the calculator. Just divide 256 by 13. You may get some value with the decimal number. Remove the decimal. Multiply that integer
9.
with the, yeah, what is the number?
9.
9. Next, 256. After 256 is a 12. 512. So 512 mod 13.
5, sir. 5.
5. Next, 1024. 1024 mod 13. 1024.
10, sir.
Ma, 10, huh?
10, sir.
10. Next, after that, 1024 into 2, 2048. 2048 mod 13.
7, sir.
7.
7. Okay. Next, 2048 4096 mod 13. Obviously, the remaining will be 1, I think.
1, sir. 1.
So all are the distinct numbers. See, no number is repeated. And
Yes, sir.
1 to q minus 1. Q minus 1 means 12. So that means for q is equal to 13, alpha is equal to 2. That is one possible. We can go for 3 also, and we have to check similar way. We can choose 5, and we have to check in a similar way. If we are getting the distinct numbers for 5, then alpha is also 5. So we can choose alpha is equal to 5, or we can choose alpha is equal to 2. So if you know any language program like Python, you can find what are the possible primitive roots for the Q13, and whenever whenever we are designing for any key exchange algorithm, then we can go for alpha for different values, but it must be less than q. Yes or no? Alpha must be less than q. Anyway, we will get less than q only by using this procedure. Is it clear to all of you?
Yes, sir.
Yes, sir.
We may give this type of problem in the exam. So, if you're still having question, you can ask.
No, sir.
Right. Now, will you try, or shall I do this one?
Sir, if we get multiple alpha values, then which one we should take, sir?
I mean, in the exam, we may provide only one value, but if you are designing or if you are doing something like a project or something, yes, generally we will go for the large values, so that the to determine the secret keys, it will be impractical. Yes or no?
Yes.
That we'll see by doing this example. Anyway, alpha is equal to 3. If we take alpha is equal to 5, what will be the problem, or what will be the difficulty? May not be problem. We can use the language program. No. So I am doing this. Please see carefully. If you want to try, you can try on your own. But see how I am doing. Okay, na? Yes. So now see carefully. Q is equal to 353. Alpha is given as 3. And what is the XA given? 97. And the XB given 10. So, I mean, when we are getting large powers, how to perform? So, first step is I am finding YA. What is YA formula? Alpha power XA mod Q. So, alpha is 3 power 97. When you put it in the calc, it may show math error. Yes or no?
Yes, sir.
Now, how to? I mean, I got one. One technique. If you are having a different technique, which is easy, you can use that one also. How I will perform this. Roll number 44. Wow, network problem or coming first time. So now 3 power 20. Anyone please put it in the calc. 3 power 20. How much is the value?
3486784401, sir.
I mean, it is not showing math error, right?
Yes, sir. Not showing, sir.
So I'm splitting this 3497 as 3420 mod 353. One more time, 3 power 20 mod 353, because no need to take a different value, so that again we have to do. Then 3 power 20 20, so 40. Then 3 power 20 mod 353, so 60. 3 power 20 mod 353, 80. Then remaining what? 3 power 70, na? Mod. Yes, I'm doing correct or not?
Yes, sir.
Mod 353. Clear? Then
Yes, sir.
one more time, overall mod 350. when we are splitting this mod or this powers, individually we have to take the mods and finally overall modular operation. So there is a proof here for this one, but we don't require that. Now tell me, anyone, what is 3 power 20 mod 353? Now, if you are having a doubt how to do this, put it in the calci 3 power 20 and divide with 353. You will get some integer, but on some decimal number. Remove the decimal number, take the integer, multiply 353, you will get some value, and 3 power 20 minus that value will give the remainder. Yes or no? Correct? This procedure. So 3 power 20, put it in the calci, you will get some value, divide with this, you will get integer part, decimal part, remove the decimal part, multiply the integer with 353, you will get some value, take the difference between this value and the 3 power 20, you will get the remainder. Yes or no? Please confirm. Did you understand this concept?
Yes, sir.
Right. So can you tell me 3 power 20 mod 353 value? I think 97 or 57 or something like that. Yesterday I have done, but I don't know. I don't remember.
73, sir.
Yes, Sigma? 23?
73.
2, 3, huh?
73, sir.
Okay,
73.
70. Yeah, I hope that's correct. Anyone? A different value if you got, please confirm. So how many times 73? 750, 750,
4
750.
times, sir.
Then what about this one? 3 power 17.
Doing, sir.
Yeah. Yes. Anyone? Please tell me. Different fellow should tell me.
So 55.
For this one?
Yes.
3,
Yes, sir.
okay. 353. Now what we have to do again? Multiply all these numbers and same procedure. Divide with, then take the integer part, then do that, and finally tell me the value. Still, suppose if you are getting a math error, you can again perform up to 3 values here, then 2 values separate, again one more modular operation. So please tell me.
Forty, sir.
Okay. This is the key, right? Sorry, not key. Yeah, key, but public key of user. Please confirm. Whoever is
Yes, sir. 40.
so please everyone confirm if this process is clear to all of you.
Yes,
How
sir.
to divide and how to perform the modular operation. So if we suppose we give 1 or 3, suppose maybe, so you have to do like this only. Now you can imagine if in place of 3, if you are using alpha is equal to 5, yes, we have to increase this, 5 power 10 only or 5 power 15 only. Then the values will come maybe 4. So we may get 7 or 8 like this. Yes, here, but to determine this 40, suppose I am the opponent. If I know the alpha and the q value, if we write a program such that whenever this value will become 40, so that all provides at least XA. Yes or no? The private key of this one. Alpha I know, q I know, suppose. By trial and error method, you can write a program such that when the value is so we may write like this. 3 power XA mod 353. You can write a program. Let's check when it is equal to 40. The XA is how much? When it will be equal 97. So this will be known by the opponent. So there is a brute force attack possible in this case. Yes, he can determine the private key of the user A, the opponent. Yes, agreed? Okay. Clear up?
Yes, sir.
Now similarly, XB is what? 10. Then what is YB? 3 power 10 mod 350. This will be, I think, easy. Yes or no? So 3 power 10 mod 353. Please tell me the answer.
$98.
98, sir.
So this is the value, not over X. We have to find the secret key. So Ka is equal to YB power XA mod Q. KB is equal to YA power XB mod Q. So what is the YB? 98 power XA is 97. Correct? Mod 350. So here KB is equal to YA, we got 40 power XB is 10 mod 350. Now this is, we can find somewhat easy when we split this 40 power. Yeah, can you 40 power 10, will it give a math error or a value? It will give 1 into 10 to the power 16, something like that. Yes or no?
Yes, sir. Yes, sir.
Try to take 40 power 5. Yeah, 40 power 5 will give something like this. 3,
Yes, sir.
3.
10240000.
Yeah. So take 2 times. 40 power 5 mod 353. 40 power 5 mod 353. Okay. Then overall mod operation. And tell me what is the answer.
$348, sir.
Overall answer? Or only for this one?
One second, sir. 348.
Overall 25 I got.
Okay, overall 25. I will check, and you also check, please. All of you following right? Please tell me.
25, sir.
Okay. 25, 14. What is the only for this one? 40 power 5 into, modulo 353.
348.
Okay, 348. All of you got this one? 348, 348.
Yes, sir.
Okay. Yes, completed. So it must be
25,
20.
sir.
It must be 25. Anyone if you know the second language program, please write down this and tell me is it giving 25 or not. But if you want to perform, I should take 98 power. How much is it giving? I don't think so. 5 will give. This 98 power 3. Yeah, 98 power 3 is okay. 98 power.
98 power 5 is giving answer, sir.
How much?
90392079.
Okay. But anyway, if it is giving 5 also, it might take so much time to compute, right?
Yes, sir.
Yeah. So don't go like this. If this power is like 20, yes, we can go up to that. But it is a 97 means, so it may take a lot of time. No need to do that. Anyone having suppose in your system, if you're having any programming language, try to do that. I'm giving assignment tip. And please put it now, what is called WhatsApp group. Yes, is it giving K as 25? Okay, now? If not, then there may be a wrong. I think it
KA
must
is
be.
25, sir.
Huh?
KA got 25, sir.
Oh, okay. So Python programming or
So, yes, sir. I used Python.
okay. So please confirm all of you. The process is clear. How to find the secret key. Um, this is the actual secret key, okay, which will be used for the further encryption process. See, suppose I mean the actually what will happen is suppose in our college uh, there is a system in DSP lab, okay, and there is a system in another CSC lab. Just example I'm taking, okay. So CSC lab there is a system 2, and DSP lab there is a system 1. So they are in the same network. Yes or no? Suppose system 1 to system 2, suppose secretly some information exchange should take in place. So what uh, the system 1 will send a public key to the system 2, or they will share initially Q1 alpha. Okay, it should be same, right, for the same two users. So they may share initially Q1 alpha, and he may this system 1 will send my private key, my public key as like this YA will be shared here, and this fellow will be shared YB to this fellow, and using the private key of system 1, and he will generate a YA, and also he will generate KA, and using XB private key, he may generate a shared system. So these two will be shared to each other. Then actual encryption process will start. Suppose he is sending some information message, some message. So for this message, again there is an encryption process. For this encryption process, this secret key will be used. And this is the suppose sender side, that is system 1. And then the receiver side, that is system 2, he will use this same key to decrypt the message, and he will get the original message. So got the point here? Yes, please confirm the procedure. So initially the key will be exchanged, then the encryption process or decryption process will start. So that process will use this shared key, right? Any question? Please.
No.
So here there is a one attack possible here, that is called man in the middle attack. That I will discuss clearly in the next lecture. But just to see here, there is a system 1, system 2, and there is a opponent or adversary and opponent. So this is XB, sorry, XA, XB private keys, and using this private keys, they will generate YA and Y. So this fellow also will choose some random numbers like the private keys, and he may generate XD1 and XD2. Generally, we say this is a Alice, this is a Bob, and this is a Dark. So Dark means a D1. Okay. So he is generating some keys XD1 and XD2. So suppose system 1 is sharing the key to the B, but this fellow will what you call interfere, and whatever the key he is sending, so that will be, do you know that one is called masquerade? Yes or no? Or there is an attack masquerade. One is called release of message contents. Yes or no? Just replaying the messages. So whatever the key YA is sending to the B, so he will capture that YA and he will share this XD1 or XD2, this fellow. Now, instead of YB, he will use this XD to generate public key. Similarly, this will also in the same way. So whenever he is sharing this public key, he will capture it, but he will share his public key to this fellow. And using that public key, he is generating some K. He is generating some K. So, but that K is already shared with this fellow. Yes or no? You got some idea what is happening? Please confirm.
Yes, sir.
So that means whatever the keys generated by the user A and user B, the opponent knows, but the user A and user B doesn't know that opponent has given the public key. So he will generate some K1, he will generate K2, but this fellow knows K1 and K2 because this fellow will share the public key to this, and this fellow also will share the public key to this fellow, and they don't know. So there is a, this called man in the middle of that. Okay, if you understand, I don't think so in the next class I will discuss, but okay, anyway, in the next lecture I will discuss this attack again and what is the problems in the first RSA algorithm. Okay, so attacks in the RSA algorithm and the attacks in the Diffie-Hellman PXA that we will see in the next lecture. Okay. So, is it clear to all of you?
Yes,
How
sir.
to find the public keys and the shared keys and what can be the problem in the Diffie-Hellman PXA. The advanced to this one will be a key, what do you call it, the digital signature algorithm that also we'll see in coming lectures. Okay.
Yes, sir.
Okay. So please revise and practice, all of you. Any question you can put it down on our WhatsApp. Okay, ma. Thank you.
Thank you, sir.
Yeah. You can attend and attend the other lecture. Thank you.